Hello, it's Duncan. I've been doing some Python programming recently, and one of the Python guidelines that I read is that if you have a class with only one public method, that isn't a class, it's a function. So today we're going to look at our classes and see if any should actually just be functions. The first of our classes that is really just a function is this logging analytics. And in this case, there's even a big giveaway, which is that we override a function type here, analytics, which is something that takes an analytics event and returns unit. And that means that we define an invoke function in order to implement the function type. So those are all big giveaways in this case. So let's see how we could go about making this into a plain function. First of all, there's this constructor here. This constructor creates an instance of a class for us, but we could change that into a function. If we did, that function can't have values, so we could remove this. And now this function here wouldn't be an override of anything because this isn't a class. Now inside a function, we can define classes, but we have to define them before we use them. So we could just move that up there. And now this function needs to return something of type analytics, and this function is of type analytics. So down here, we can just return a reference to that function. So what we have here is a function with a capital letter that returns another function type. In order to do it, it defines a function inside itself and then returns a reference to it. Let's just check that does everything we expect it to. Well, that passes the tests. Now this is a little complicated. We could solve some of the problems by removing the envelope from the function itself. There's no reason this shouldn't just live outside on its own. Check that works. And now we can inline this function, the function within a function, and even make that an expression body. And by making expression body, we've actually just got a lambda here now. So this is saying that our logging analytics is a function that returns another function, and that function is defined by this lambda. It takes an analytics event and does what it takes to do our logging. Only one thing left, which is that Kotlin thinks that functions should start with a lowercase letter, where we had a class before that started with an uppercase letter. So let's just rename that with a lowercase l and run the tests. There we go. Let's look at those changes. Well, analytics, we've seen how we've changed that. The tests, well, all that's changed here is the case of our function. In fact, there is a change here because this is actually calling a Java constructor, and Java constructors are different than plain old functions. So that's a difference that will actually be in the bytecode that would require a recompilation of anything that used our code. At the moment, though, everything is in one module, so that's not a problem. And in roots, again, all we've changed is the function that we're calling from the constructor to the function. And that's because previously analytics was a function type, and here we are returning an object that implemented the function type, and here we are returning the result of calling a function that returns a lambda, which implements the function type. Okay, let's commit that. So let's have a look now at our other action type class, which is stock. Again, this has only one public method, which is stock_list. And we use that here. We pass a reference just to that method here into list handler, and list handler uses it as just a function. So that's another bit of a giveaway, really, that stock is really a function in disguise. So let's go about converting that. We'll take the same sort of action. What we'll do is we'll say, let's make stock into a class that implements the interface of its one method. So that would be this function signature here. So it's going to take an instant and return a result with a stock list. Now, for some reason I don't understand, you can't give names to these parameters, so we take that out. And now in order to make that happen, we need to implement an invoke. Here it is. Let's just rename that to be now. And what should this do in order to implement? Well, it can just call the existing stock list method. So that will compile, but it doesn't change any of our behavior. But now that stock implements this function type in roots, instead of passing stock list, we can pass stock itself. So let's do that and run our tests. Okay, now we can return to stock. And quite a good trick now is to swap these two round. So we will call this one our invoke, and we'll call this one our stock list. This will call invoke. If we run that, it should not change our behavior. But now we can go through the calls of stock list, replacing them with the invoke. So here's one. So if we inline it here, that will be invoke, and we know we can just remove that invoke. Same is true here. Inline this one, replace invoke. Two more. So this will be stock on now, and let's see where that works. So now our stock is a class, but it's a class that's being used as a function type. Check there are no more callers. They're all gone. So now we can go to stock and delete this one. Okay. Now what we want to do is we want to make stock a function, not a class. And as before, we'll just rename this to be a fun. And now it's a function, we can't have values. So this is just a function, not a constructor. Now, this doesn't make any sense, but we can still call it invoke. And what we have here is a function. So the function runs from here down to here. And inside this function, we have two function definitions. One is invoke and one is updated. You can't have private functions inside another function, so we can take that out. And they have to be declared in the order they're used, so we have to move this up above invoke in order to have it compile. And then finally, this function, the one called stock, needs to return something that is instant to result a stock list. And that thing is our invoke function. So we can say return invoke. Let's just see whether that works. And it does. Now that allows us to inline this. And you'll see that IntelliJ has replaced invoke with a lambda that is the same body. So now this is not used. And then finally, IntelliJ doesn't like functions with an uppercase letter, so we can rename this to stock with a lowercase s and run the tests. Let's have a look at those changes. So where we were previously building a stock with the stock constructor, now we're calling a function that returns something of the function type. And that means that instead of saying stock list now, we just say stock now. This is a function. And in our roots, instead of passing a method to the reference, we can pass the result of calling the function. So we say stock here and we pass it into here. Now, though, we have to ask whether this is a good idea. Personally, these nested functions I find a bit confusing. This function needs to be nested in order to access value of zone ID, for example, we use here, and our update we use here. So if we take them out of here, we need our updated function to take those items in here. In a class, of course, these were values, and so this method had access to them as properties of the class. So we should ask ourselves, is this better or worse than the code it replaces? Let's have a look. Previously, we had a class with a single method and had access to all of these properties. And this private method also had access to these properties. Now we have a function where the two nested functions inside it have access to the parameters. When this code is compiled, the compiler will actually generate a class to carry around this stock file and zone ID and so on in order to pass it to both of these functions. So there's not much difference in efficiency. So we're left with which is more understandable. Personally, in this case, I think I prefer the code as it was. So let's just revert that. There is a refactoring I'd like to do on this class though, which is around this update function. Looking into it, we have a silly little update here that is the function that's passed into stock when we create it. So in roots, we pass this update items. Why do we parameterize that at all? Well, because we didn't want our tests of the stock class depending on the details of how we update individual items. So in our stock tests, we pass in this simple update items, which just copies item rather than using its update. However, there is this duplication of this item map. So both of these actually run over every item. They differ only by what they do. This says item updated by, which uses the item type. And this just says, we'll treat all items the same. We'll just decrement their quality by the number of days. So it would be better, in fact, if this map happened in stock. So let's see how we go about doing that. What I think we'll do is we'll add another parameter to this. And we'll put it here, and this will be a functional parameter. This will be item update, how you update an individual item. And this will take an item and the same other parameters as this, so the number of days out of date and when it is. And that will return an updated item. Now, in our production code, that should be our item updated by. So let's just pass that in. Here, that says item. And in our test code, where we're passing in simple update item, which is here, this will be what we're doing in our simple update item, which is this thing here. So put that in there. Now, we're not actually using this yet, so that should now compile and pass all the tests, as it does. Now, when we update, instead of calling this update, we can use this item update. So our items is now items map for every item, passing the item and the days and the date. Little conversion here and finish the brace. Check that is still running. Good. And now this is unused, so we can remove it. That makes this unused, so we can remove it. And that makes this unused, so we can remove it. So what we've done is we've taken the common code, the fact that both of the update items mapped over, and we moved it into stock. It might be slightly nicer if this item was the receiver. So we can just say that this is a function that takes an item as the receiver and then days and returns an item. And then in here, this would be it item update. That may well build in other places. Not quite, because in here, we have to make this not take an item anymore, but that be the receiver. So that would be this copy, and that would be this in here. Little reformat in here. We don't need that on anymore. And now we simplified not only the signature of this, but we've removed some duplication from our code. Run the test one last time. And I think that's good to go. So this is change stock to take update of item, not item list. 3 warnings. An unused import. Well, let's face it, an entirely unused file. So let's delete that. And then some more unused imports over here. So we've evidently simplified things. One last run. Commit and off to production. Sometimes, as with this logging analytics, it simplifies things not to have a class, just to have a lambda with closure over some parameters. And sometimes, as with this stock, I think it is simpler to have a class with some properties that can be referred to by other collaborators that are namespace into this class. We have to use our engineering judgment to work out which is better in each case. If you disagree with me about these 2 cases, then please let me know in the comments and we can have a chat. There are 2 chapters looking at the relationship between functions and classes in the book I wrote with Nat Price called Java to Kotlin, a Refactoring Guidebook. So if you enjoyed this, I'm pretty sure you'll enjoy that. Details of the book are in the show notes below. Thanks for watching.